Hello everyone, and welcome to our next lab lecture. We're going to be talking about Newton's second law of motion. So what is Newton's second law? In an inertial reference frame, the vector sum of the forces F on an object are equal to the mass m of that object multiplied by the acceleration a of that object, or F equals ma. We have been working our way up to this, so I'm sure that's not the first time you've heard this. The second law of motion is the real law of motion, as the first and third laws can be obtained from it. We won't be going too far into what the first and third laws are, but they are good to know. Okay, for the last several weeks, we have been talking about forces. What is a force and what are the categories of force? These are questions you should know the answers to now. What types of forces are shown here? You have a contact force, which is applied. What do we have here? A non-contact force. Magnetic force, which we haven't talked about, but also works for gravity too. What types of forces shown here? An applied force and friction through the tires. Here we have contact force, drag. Non-contact force, the force of gravity. And what do we have here? Non-contact force, known as the force of gravity again. And a contact force, which is the normal force. All of these we have discussed before in the lab one way or another. Well, contact forces are interactions between objects that touch, such as an applied force, a spring force, which we haven't talked about yet, but we will have a lab on that in the not too distant future. Drag force, which we won't be dealing with in this lab. Frictional force, which you have dealt with already, and the normal force, which you have dealt with already also. Non-contact forces attract or repel even from a distance. Magnetic force, which you will deal with next semester. The electric force, which you will deal with next semester. And the gravitational force, which we have talked about already. A force is a push, a pull, or a twist. Applying a force can change an object's velocity. And what is the SI unit of forces? Right, the Newton. Okay, acceleration. What is acceleration? Acceleration is a rate change in velocity. What we've been doing in this lab so far is finding the velocity by finding your change in velocity, which is your delta V, and by taking your initial minus, or your final minus your initial velocities. Applying a force can change an object's velocity. So if there is no force, the object's velocity won't change. Newton's second law of motion. An object's acceleration depends on the strength of the unbalanced force acting on it and the mass of the object. A equals m over F, force, mass, but you know it as force equals mass times acceleration, F equals ma. Pull on a wagon as hard as you can, applying the same force. What will happen? You have a larger acceleration with a smaller mass and a smaller acceleration for the larger mass. Mass versus weight. Mass is the amount of matter that an object contains. Weight is the gravitational force. A measure of how strongly gravity pulls an object. Your weight depends on the strength of gravity, which means different acceleration means different forces. If you're on Earth or you're on Jupiter, your weight's going to be quite different. So weight depends on where you are. On Earth, acceleration due to gravity is 9.8 meters per second squared. On the moon, it's only 1.6 meters per second squared, but on Jupiter, your acceleration due to gravity would be 26 meters per second squared. Atwood Machine is where you have a pulley with equal masses and at different heights. What happens when you let go? Use what you know about forces in Newton's second law of motion. You can use an Atwood machine to measure frictional forces and force of gravity. Okay, free body diagram. We talked about this last week and the week before, and this won't be the last time you will hear about it either. Free body diagram is a diagram for each body in the system depicting all the forces acting on parts of the system. The equations of motion obtained using free body diagrams can also be solved to find unknown quantities in the problem. So here's your free body diagram. You have the normal force and applied force, gravity, and friction. Of course, the person who set this up did not use our notation that we use, but that's okay. Okay, so just to review some of the information that we've covered so far. Newton's second law can be written as force equals mass times acceleration. From Newton's second law, an object acceleration depends on the object's mass and the strength of the unbalanced force acting on it. Your weight will be different on other planets because the acceleration due to gravity is different. Some things to think about. And that should be all. Well, you guys have a good week, and we'll see you in lab.